see here where it says prune. So what's happening is it's canceling. It's basically destroying the connection to router 2, and it's saying, hey, look, for the return traffic for the multicast group, instead of going through router 2, go through router 1. And that's what we're seeing here. So our outgoing interface here, we're seeing it forwarded to fast Ethernet 00. Okay, so that multicast traffic was being forwarded to, our destination here, which is, this guy down here, 192.168.34.4. That's the guy who joined the multicast session. So again, we're learning it via serial 10. We're seeing it inbound to router 3, that multicast stream. Okay. We're pruning it via serial 11, our connection to router 2. Because if you look at the routing table again, you see here that our best path to 192.168.10.0 is via 110. So that's basically how RPF works. If we were to go to router 1 now, what we should see on router 1 is that it's pruning its serial interface to router 2, which would be, let's see, serial 10 should be pruned on router 1, and it should be forwarding on serial 11, and it should be the multicast stream should be inbound on its fast Ethernet 00 interface. So if we go to router 1, we'll show IP route. You can see that the traffic has been flushed from the routing table. So if we do again on router 0, if we start that traffic again, just generate some traffic to 224.1.1.1. Now if I do a show IPM route now, what we see is, again, what I said we would see here, we're seeing the incoming multicast traffic on fast Ethernet 00. Then we're seeing the outgoing interfaces here, serial 10, it's pruning, okay? And that's our connection, again, that's our connection to router 2, because that is not the best path through the network. And then we're seeing here serial 1/1, it's forwarding on. So the RPF in this case fails for serial 10, and it passes for serial 11, because that's the best path. So if we do, again, if we do a show IP route, we can see here that the best path is through serial 11, and where we're forwarding out serial 11. So again, router 2, it doesn't need to partake in this multicast session because it doesn't have any local interfaces on it that are configured to join our multicast group.
Nerd.
So that was my wife calling me a nerd, but when I buy her a big diamond ring, I'm pretty sure all that'll change. So anyway, that's PIM dense mode multicast, and that's just a look at the basic how to get it up and running on the routers, how to verify your PIM neighbors, how to look at the reverse path forwarding, and how the RPF check uses the unicast routing table, to determine, if if the check fails or not. If the packet coming inbound has the correct IP address, and it sees that it determines which interface it would use to go in the reverse direction toward the source IP. And it basically just compares that with the interface on which the packet was received, and if they match, then it accepts the packet and forwards it. Otherwise, it drops the packet. So that's it. That's the multicast lab1 basic configuration of PIM dense mode. Actually, I thought I was done. I'm just going to do one more thing here. I just want to show you this command, show IP RPF, and then the IP address. What this is going to show you here is the reverse path forwarding interface for the specified IP address, the RPF neighbor, and the the subnet and the subnet mask, and the RPF type. So you can use this in troubleshooting to make sure that your your multicast your tree is up. Basically your whole path is good. So again, if we go into router 1 to do a show IP RPF, we can just check, like if I do R1, if I do show IP RPF and then 192.168, 10.100, we should see in here RPF information should be a fast Ethernet interface, which it is. That's where we're learning it. It's directly connected. So if we go to router 4 and do a show IP RPF, the same 192.168 10.100, which is the source of the multicast traffic. You can see here command is kind of slow. You can see here RPF interface is FastUnit 00. It's got the neighbor again and the mask, the unicast, RPF type. It's learning that via our EIGRP process, which is EIGRP1. So if we do a show IPM route, well, it's timed out, of course. If we go back here, generate the traffic again, you can see here you can see that source again. Okay. I think that's all I wanted to show you guys in this video. Maybe next we'll do PIM sparse mode in the next video. I'm not sure what direction I'm going to go yet, but hope you guys have enjoyed this video, and I hope to see you guys again soon. Thanks. Bye.